to talk about measurements of angles, and this is something that might be somewhat familiar to you, but that we're going to talk about it in a way that maybe you've never heard before. Okay, so we're going to talk about a few things that you need to know. Now, this is the terminal size, this is the initial size, and when we're talking about a positive angle, we're normally going from in a counterclockwise position. Okay, so a positive angle would be considered like going this way, essentially. All right, so counterclockwise would be positive, and clockwise would be a negative. Okay? Now, having said that, there's some Greek letters that kind of give some students trouble, but theta or alpha, or I think that's beta, I could be wrong. All of these are just capital Greek letters that delineate that they're just angles. All right, so all of these are actual angles. Okay, the measures of those, it can be measured in either degrees or radians, but to figure out what that means, okay, we're first going to talk about this. Now, the angle can be found by dividing the arc length divided by the radius. Again, arc length by radius. Right? So, for example, if I ask you, what is the measurement of that angle? Well, all you would do for that is that you would divide. Remember, this would be the arc length divided by the radius. Right? So 5/2 or 2.5. That would be the angle on that one. Okay, now on this one, notice that it tells you that the arc length is r. So this would be r over r, which is 1. And I think the whole reason they do that is to let you know that a radian, which is that's what this is, all right, a radian has no units of measure. So let me put that here. Radians have no units of measure. And by that we mean, like, for example, when we talk about degrees, we put the little symbol on top, right? But these are actually radians, so we wouldn't do that. Okay, so moving on to the back now. Hopefully that was pretty simple for you. All right, 360, right? 360 degrees, if we're talking about the same formula, would be the arc length. In this case, 360 degrees. If I go all the way around, that would be the circumference. Alright, and if I divide that by r, then well, then I would get what that would mean. So the circumference is actually, the formula for is 2 pi r. And if I divide this by r, well, lo and behold, 1 revolution is equal to 2 pi, right? And that actually becomes very, very important on this. But not only that, okay, if we know that 360 degrees is 2 pi, and this is actually the radian measurement, by the way, and this is the degree measurement. If I divide this by 2, then I get that pi is equal to 180, okay? So that is pretty important because this essentially gives me a way to convert degrees into radians and radians into degrees, and this is how we do it, right? If I have some measurement in degrees, okay, I can then multiply that times pi over 180, and that's the conversion unit. Similarly, if I'm doing radians to degrees, I would do the same thing, but I would have x in terms of radians, and since we have no measurements, I just have to literally write radians. And I'm going to flip that around. Remember, I always want to have on the bottom whatever I want to cancel out. So for example, degrees cancel degrees, and I end up with pi, which is the radian measurement. So it's the same idea. If I want to cancel radians, I would put pi, and I would put degrees up here. So that would cancel my radians, and I would end up with something in degrees. All right, so let me give you an example. If we have negative 225, which remember that would be going clockwise, and I'm just going to put this as degrees, so I have 180 on the bottom here, and I have pi up here. That would give me, let's see if I reduce this, that would give me negative 5 over 4 pi. Alright, remember, on your calculator, all you have to do is put 225 divided by 180 and then reduce that. and you would get 5/4 and you just attach the pi to it. Don't worry about putting the pi's on it, just leave it like that. Alright, that's what we want when we convert to radians. We want to leave it in terms of pi. Alright, now to convert 50 degrees to radians, one more time, same idea. We put 50 here, and then we have pi 180, and then we're just going to reduce 50 over 180 pi, which in this case would just be 5 pi over 18. And that's that for that one. Right, now if we're going backwards and we're talking about converting, in this case this is radians into degrees, then what we would do is that we would have negative pi over, let me write this, over 3, and we have 180 here, and we have pi down here. So remember, this is a nice thing. The pi and this pi would cancel out, and then I have 180 divided by 3, which in this case is negative, well, excuse me, that's the negative came from here, negative 60 degrees. Alright? Now finally on number 6, if I have something like this, it's the same idea. Right? I'm going to put it on the same little conversion table here. Remember, if I'm trying to cancel pi, well, pi I'm going to put that on the bottom, and the conversion is 180 on top. So pi's cancel. Let's see, that 4 and that 180 would reduce to 45. So I have 3 times 45, which is 135 degrees. Okay, so that's essentially how you convert radians to degrees and degrees to radians. Now, finally, we're going to talk about a couple of things called complementary and supplementary angles. Now, with complementary angles, all right, they have to be 2 positive angles that add up to 90 degrees. And similarly, with supplementary angles, not somebody wrote angels here, my bad. They have to add up. 2 positive angles have to add up to 180 degrees. All right. So again, complementary is 90. Supplementary angles are 180. So this is essentially how you would find them. It says find the complement. Remember, complement is 90 degrees. So I would grab a 90 degree angle and I would subtract 46, and I would find out that the answer to that would be 54, I believe. Let me check my notes. 44, excuse me. Okay, so I'd have 44 degrees, so that's my complementary angle. Okay. Now same idea on this one, but now as a supplement, so I have 180 degrees because they have to add up. I would have 124, and then that would give me 56 degrees. So that's my supplementary angle. To find the complement, now all of these from now on are in radians. Right? So if you see it like this, don't freak out, they're just in radians. So to find the complement, I would have pi over 2, and you may not know this, pi over 2 is 90 degrees. Alright, so it's pi over 2 minus pi over 12. Now I need a common denominator to multiply those, so I'm going to multiply top and bottom by 6. So that's 6 pi minus pi, that will give me 5 pi. And notice that on the bottom I would have 12. 6 times 2 is 12, and I have 12, which is what allowed me to add them or subtract them in the first place. Excuse me, this is a positive 5 over 2. 5 over 12. 5 pi over 12. Alright, and then notice, by the way, that I'm not really doing anything with the pi other than just rewriting it. Okay, I'm just adding terms that have pi on it. They're like terms, essentially. Alright, on number 10, same idea. Just a little bit, there's a little bit of a quirk in this one. Complement, so I'm going to subtract this from 90 degrees. Right, and if I have a 6 here, I need a common denominator, so I'm going to multiply top and bottom by 3. Right, so that's going to give me 2 pi over 6. I notice that that's 3 pi minus pi, that's 2 pi. And on the bottom I have 6 and 6, so that's my common denominator. Now I can reduce that to pi over 3. So this one's pi over 3. Let's see, I'm probably going to skip all the way down. Oh, supplement, I should at least do one. So for supplement, remember, they have to add up to 180 degrees, and 180 degrees in terms of radians is actually pi. Alright, so if I subtract 5 pi over 6 from pi, I need a common denominator, so this one's a little bit easier. To find a common denominator, all I have to do is multiply top and bottom by whatever this denominator is. In this case, I would have pi over 6. Okay. Now to go on to the end, number 13. Now again, this supplement, same idea. You can do this on your own, hopefully. I'm just going to write it down, let you figure it out, but I believe if you figure it out correctly, you just get pi over 3. So try to figure that out. Right, and this one is a complement, alright? So the complement is 90 degrees, so this is pi over 2 minus 5 pi over 6. Now, maybe you already see the problem with this, but if you don't, go ahead and do the math, and that's going to show you that something is not quite right. Now, this is going to be 3 pi minus 5 pi is negative 2 pi. Common denominator was 6, right? So this is going to be negative pi over 3. Now, remember, by definition, the two angles are complementary if the two positive angles, they add up to 90 degrees, right? So the sum of them. So because this is negative, this really doesn't imply, so that one really cannot be an answer, okay? All right, well, that's it for that.